wrote a hello world smart contract, a counter smart contract, created what we talked on primitive types, variables, and then constants. So today we'll be doing immutable variables, reading and writing to a state variable, then ether and way, and gas price. So so let me create a let's start with immutable variable. So let me create a file called immutable dot so first thing, pragma solidity, specify our compiler 0.8.4, then create the contract immu immutable contract immutable. So now immutable variables are just like constants here, but it's just that they are defined in a constructor. You get they can be set in a constructor, and then once they've been set, yeah, they cannot be modified. They can't be modified. Let me use an example. So let's say I create an address here. Address, I make it public. Then I call it my address in capital letter. Constants. When you are naming constants, you always put it in capital letter in this convention. But right now, since we're using immutable is just a type of constant. So you put the immutable keyword, then the address. Then you can just make it like null for now. Address public who ends with neither. Yeah. So now after doing this, then I now have to define a constructor. A constructor is just a function, even in normal languages like JavaScript. A constructor is just a function, or you might call it a method, a function that is executed at the creation of a contract. So once this contract has been what is being deployed, the constructor is initialized. So now from the constructor here, I can see from the constructor, I'll now see my address is equal to, I'll now, we talked about global variables, state variables, and local variables. So a global variable is the one that can be gotten from the blockchain itself. So I can see message.sender. So I'll see this my address is going to be the message.sender. That's the person that is calling the contract. That's the person calling the contract. So message.sender. So this my address will be assigned to message.sender. Um, let me give another this thing too. Can say you int 256 um my integer. I'll make it public, and then I'll make it immutable. So now I would assign my int to be equal to, from here now I can just see underscore my, let me call it u int underscore my u int. So I'll just assign this here. So I have to make this type uint 256. So let me rename this my uint. So now if I deploy this contract, immutable. So like I said, at the point of the contract creation, the constructor function is called. You get the constructor function is called. So sorry. The constructor function is called. So you can see here, before I deploy this contract, it's telling me to put an input because we define in the constructor that okay, we must put this integer, my int. So if I call my int 5, now I'll be able to deploy it. Now when I deploy it, if I click my int, it's returning 5. If I click my address, it's returning the address that deployed this contract, which is here. Um, yeah, this is the address. You can see it's 053DB. This account that is here. This is it. And then that's the address that deployed this contract. So that's why, because that's what is calling this my address variable. So it's assigned message.sender. I don't know whether you get me.
Yeah, I'm following.
Okay, okay. Yeah, so yeah, that's just it on immutable. So whenever you want to declare anything inside your constructor function, just if you want to like assign a constant, you know that when you assign it once in the constructor, it cannot be changed. You can't change the state any longer. So you just define it as a state variable, but it should be a constant. And the kind of constant, it should be an immutable constant. So you now
So
like say,
hello, sorry,
yeah,
sorry. Right. Please, Excel said he was going to step away for some minutes. That if anybody tries tries to join, you should give him a call. And somebody is waiting.
okay, someone is waiting. Okay, let me call him. Hello? Yeah, yeah, I'm good. Can you like let someone on the call? Yeah. Yeah, so welcome Daniel Chief.
Thank you, sir.
Yeah, Chief. Yeah, so like before you joined, I said I discussed on what we are going to discuss today. So we're talking about immutable variables, reading and writing to a state variable, eta and way, gas and gas price. So um, first of all, talking about immutability. So immutable, that the immutable keyword in Solidity is basically used for constants. You know, we treated constants in the last class. So, but then the difference between immutable and then a pure constant is that immutable is once is declared inside a constructor. Once you declare your state variable outside the constructor, then you now assign it in your constructor. And then once you assign it, you cannot change it again. You can't change it again. So, and I used an example here which I put the address. I call this address public, then I call this my address a state variable. And then my int is also a state variable. Now, inside the constructor function is basically a function that is called, that is initialized at the contract creation, the creation of a contract. So now I assigned my address to be message.sender. Remember in the last slide, we talk about state, we talk about variables, and we have states, variables, local variables, and global variables. And now, message.sender is one of the global variables in Solidity, which you can access anywhere in Solidity from the blockchain. And the message.sender is the person that is calling that particular form. Sorry, is the person calling that particular function or trying to execute that particular transaction. So in this case, now message.sender is the person that's deploying the contract because it's assigned in the constructor. So now when I deploy the contract here, let me deploy it. So now if I come here, if I want to deploy it, you can see that the button here is not is saying an input is required. That's because in the input in the constructor, I put it here that we need to put the int like an unsigned integer as a parameter here. So I have to put it. Let me assign it 9. So when I put 9, then I can now deploy it. So once I deploy it, if I click on my unit, it's going to my uint is returning 9, which is what I assigned here because we are assigning to this variable here, this local variable here. So, and then if I click on my address, it's returning the address that deployed this contract. If you want to be sure, if I copy this address now that is returned here, this is it. And then I copy the address that deployed the contract. This is the address that deployed the contract, the account. Let me copy it. You can see that they are the same thing. Can you see what I'm doing?
Yes, yeah.
Yeah, exactly. So they are the same. They are the same thing. So that's just it about immutable. Immutable. Immutable is still a constant, but it's just that is usually declared in the constructor of um, of the smart contract. So let's go to the next one. So we'll go to reading and writing to a state variable. Yeah. So now if you want to read, if you want to write, sorry, if you want to write to the blockchain, you are updating the state of the blockchain. So that means you are going to send a transaction. You get, so you need gas fee. You're going to need gas. So let me just see reading and writing to a state variable. So let me create a new contract. I'll just call it let me say simple storage. This is a popular example, simple storage dot sol. Now I'm going to copy this I will use here and call contract simple storage. Now in this simple storage now, I, I can declare a function here called set here. Now I'll declare another function called get, because getting is to read from the blockchain, and then for setting, that means you are updating, you are writing to the blockchain, writing to the blockchain. So that is, you will be sending a transaction which requires gas. So you need gas for this. And then for this, for getting, you are just reading, you're just reading from a state variable. State variable without sending a transaction. So it's more like in when you're doing backend, when you're doing CRUD operation, read, write, update, and delete. So now you are basically um, writing to the blockchain or updating the state of the blockchain. So now I'll declare a state variable to store a number. Let's say uint 256, and then I'll call this public, and then number number. Now to set this, I'll say uint 256 num, and this would be a public function. And then I'll just state that this number, which is the state variable, is equal to this local variable num. So here now I'm sending a transaction and I'm updating the state. You know, when in the last time when we talk about variables, we said local variables. This num here is a local variable, is not stored on the blockchain. As soon as this function finishes executing, we are done using it. You get, so it's not stored on the blockchain. But this is a state variable which is stored on the blockchain. So we have to update the state of this blockchain, assigning it this num, assigning it this num. So to execute this function, we are going to send a transaction and we need gas. We execute it with gas fee. So now to get from the blockchain now, we call this public, and then returns, you have to state what is going to return during 256 here, and then say return number. Now if I hover on this, saying view can be restricted to view, I'll still explain what view is later on. View, a function can be can be view or pure. You get. So that will be later on. We'll go on to that. So, but then we've done this. Now let me execute it. Let me deploy it. Sorry. So now if I deploy this contract, you see that if I click number is showing 0. Number is 0 here. Now if I set number to like 800, click on this. I'm sending a transaction. If I open this place here, if I open here and then so I think you can see my screen now. So now you can see when I opened here, say OX1 transaction mined and executed. So this sent a transaction. When I hit set, when I clicked on set, let me do it again so that you guys will see. If I click on set, you can see transaction to simple stuff storage, and then it sent this transaction, and then it returns things like the block number, the hash from to the gas. This is the gas, the transaction cost, other details. Sorry, and other details. Now, if I click on get, you can see that for get, it did not send any transaction. I don't know if you guys are seeing what I'm saying. It did not send any transaction because it's just reading from the state of the blockchain. And you can see that there's no gas. There's nothing like gas here. I don't know. Do you guys get me? Oh, wrong. So you see that there's nothing like gas here. You get so I think that will be all on reading and writing from the blockchain. So let's go to the next thing, which is Ether and Way. So Ether, let me call this Ether units dot Sol. So if I call this contract Ether unit, now so the way we have $1 is equal to 100 cents. So it's the same way we have got to 1 cent. We have one ether or ETH, call it ETH. 1 ether is equal to 10 raised to power 18 way. 10 raised to power 18 way. So now if you say you int 256 public 1 way is equal to 1 way got to 1 way, and then we say bool public, that is one way. So is one way equal to one way equal to one. So we're trying to say is one way equal to one. One way is equal to one. If it returns true, then distance returns true. So it's more like we are saying one way is equal to one. Now we say you int 256 public. We're moving on to GUI. So if you say one GUI is equal to one GUI, and then one GUI is equal to one GUI is equal to 10 raised to power 9 way. Because weight is the smallest unit of measurement. So that's it. Yeah, I'll call it measurement in solidity. So 10 raised to power 9 weight. So if I say public bool public is one GUI is equal to one GUI equal to 10 raised to power 9. And the way you write 10 raised to power 9 solidity is 10e9. If it returns true, then it stands. Then we move on to one ether. So you in 256 public one ether is equal to one ether, and then one ether is equal to 10 raised to power 18 way, since way is the smallest unit of measurement. So we say bool public is one ether is equal to one ether equal to 1e per 18. So if I deploy this contract, you can see it's returning true. Is one ether is true. Is one ether here is returning true because one ether is equal to 1 raised to power 8. 1 raised times 10 raised to power 18 way. Is one way is returning true. Is one way is returning true. Yeah. So you can see that one ether is returning 10000 to like 18 because the smallest unit of measurement is way. One GUI is returning one and then 9 zeros, and then one way is one. So that will be all on ether and GUI. So now we'll be moving to the last thing for today, which is gas and gas price. So let's create another file which we'll call let me copy this. We'll create another file which we would call gas.sol. So say contract gas. So but first of all, first ask yourself this question: how many ether do you need to pay for a transaction? How do you do that calculation? Yeah, to pay for a transaction. Now, the way you calculate it there, you're going to say um, the gas spent multiplied by the gas price is the amount of ether you're going to spend on a transaction. Ether amounts. So gas spent times gas price, where gas is the unit of computation. Then the gas spent is the total amount of gas used in the transaction. And the gas price is how much ether you are willing to pay per gas. So this is the explanation. So if you want to calculate how much ether you're going to pay for a transaction, is going to be the gas spent times the gas price, the gas you spent. And then the gas is the unit of the computation, which we are doing here. The gas spent is the total amount of gas used in the transaction, and the gas price is how much ether you are willing to pay per gas. So, and you should note, and put this note, transactions with higher gas price, have higher block priority, higher priority to be included in a block. I told you the way the EVM works, the Ethereum virtual machine. That's the consensus mechanism, proof of stake. So it's according to your uh, how will I put it now? According to how much you are willing to pay in gas, that's how a validator is going to be like assigned to you, and then he's going to uh, validate your transaction. You get in a block. So if you are paying a higher gas fee, if both of us want to execute the same transaction at the same time, you get, if I pay a higher gas fee compared to you, my transaction will be executed first before your own. So, and then let's also explain gas limits. So gas limits, gas limits is the max amount of gas you are willing to use for that transaction or for your transaction. So you're the one that is going to like set that one. And then your block gas limit is the amount of gas allowed in a block. So this one is set by the network. The block gas limit is the amount of gas allowed in a block. So, and it's set by the blockchain network. Why this one, the gas limit is set by you. It's the max amount of gas you are willing to use for that transaction. So now let's do an example. So if I have you int 256 and then I say public I say this is equal to 0. So if I say function forever, but I want to create a what they call this thing, an infinite loop, an infinite while loop. So if I say while forever public, see while, sorry, I say while true, we've not gotten to loops yet. So while true, you can say I plus equal to 1. So there's no way where this function is breaking. So this function is going to use up all the gas that you sent. Um, um, if it's going to use all the gas that you sent, and the transaction is going to fail. So, and state changes are undone, and then your gas spent are not refunded. So let's run this. Um, let's run this function. So if I click deploy and if I click I is showing 0. Now if I click on forever, you can see that the transaction is pending, is pending. It's going to use up all the gas you get. So let me stop this transaction. Spending. So I have to stop the. You can see it's pending, so it's going to keep on running forever and then to use up all the gas. So later on, see it return the transaction field. Transaction field. Then it used up all the gas. So I think that will be all on gas. We talked about immutable, talked about reading and writing to the blockchain and updating state variable. We talked about ether units, that's units of transaction and um, amount measurement is solidity, which is the smallest unit is in Wei, followed by Gui, and then followed by ether. So um, you can see you may you may want to continuously increase the gas limit of the transaction went if the transaction went out of gas. So it went out of gas. So I think that'll be all for today. That'll be all for today. So you can go through it um in your this weekend. Go through it. Make sure you understand it. Then till next week. So can you guys hear me?
Yeah, loud and clear.
Yeah. Is there any question? Do you get what I said?
Is there an estimate of gas for a code or for a contract when running it? Is there an estimated gas you are allowed?
Uh, no, not really, not really. The gas is going to depend on. It's going to be automatically calculated. It's going to depend on the way you're executing your function, the way you write your smart contracts. Are you using like best practices? That's why they say like you optimize. There's what they call gas optimization in Solidity. So you optimize your code to make sure that your your Solidity functions execute with as minimal gas as possible. You get so you try to like optimize your code up to that level. So yeah,
Okay, noted.
yeah. Any other question? Okay, so in the absence of no question, uh, next week we'll be looking at under mode 2 if and else statement, for and while loops, mapping an array, enums, struct, um, data locations, um, transient storage. So I think before we start like um, building like I think that will be in like I think week 7. That's when we start building like like full smart contracts. But for now, taking them like bit by bit, till we get to advanced concepts in Solidity like try catch, uh, how to color that contract, um, what again? Events, error handling. You get things like that. Inheritance. You get so those are advanced concepts in Solidity. So let's just keep going, keep on learning, read up more, try to solidify all that we've learned. This is just week 2. We're still going to week 8, so that's 6 more weeks for us. So, yeah. Thank you for thank you for joining the call. I know
Thank you
I'm
for
always
the
like
call.
sure, and I just hope the time is okay with you guys because we're supposed to be having by 2, but sometimes uh because of work and some other stuff I used to meet up, so I'm really sorry for that, but um but it should not really be an issue. Most of us are devs, so we work at night. So I think that'll be all for tonight. Then see you guys next week.
Okay, good night.
Yeah, good night. Chief.